we're going around our triangle, we need to see an angle. And then right next to that angle, we need to see a side. And then right next to that, we need to see another angle. So we have to see that angle side in order, angle side angle, excuse me, in order for us to use that. So depending on how you want to mark things, you can either draw out, okay, here's an A, here's an S, here's an A. So this is ASA. So this first triangle is. Look at the next one, you've got an angle. Well, then we got another angle, then a side. So we have to have a side in between here. Then our last one, we've got an angle side angle. So it looks like it's our first and our last triangles, which are going to be congruent by ASA. If you need to write a congruence statement, it doesn't say to do that, but if you did, you'd say triangle. For example, PRQ is congruent to, and since I started with P, that's the one with one arc. So I'd start with B, then go to one with two arcs, which is W. Oops, I forgot my triangle symbol. Triangle VWX. So when it says congruent statement, that just means you're going to rewrite which triangles are congruent to each other. You have to match up their letters to make sure that you're talking about the same order in each of those triangles. All right, number 2. Has anybody tried number 2 yet? Looks like ABC is ASA because you got the right along the bottom there, and that looks like EFD as well. So those two triangles would be your ASA. The third one would be a correct order for using one of our postulates. That would be SAS. Now, writing your congruent statement, you start with the A, go A to the double arcs, which is C, so ACB would be congruent to EFD. So you could just follow along, make sure your letters are matching up. So you will be asked to write congruent statements, or you'll be selecting, since we're doing an online digital test, you'll be selecting multiple choice which congruent statement is correct. And you have to make sure those letters are matching up so that you can represent that congruent statement correctly. All right, you guys ready to hit to number 3? Do a big proof? Here we go. It's time. The big proofs, writing your own. Okay. These boxes are a little bit smaller, so you're going to want to write kind of small if you're working on this by hand. But if you're working online, you should have, or digitally, you should have enough room to fill all this in. So just focus on number 3 first. So number 3, we're given a diagram up here. The one thing I do like about having a hard copy is you can then kind of mark things as you find certain things congruent. Then you can start to mark things and start to prove what you need to prove. When you're writing a proof, the very first thing you do is you list the given information. So we're going to make a 1. So our first step is we're going to say the given information, which is angle BAC, is congruent to angle DAC, and segment AC is perpendicular to segment BD. And then our only reasoning is given. So when you're writing proofs, and we're doing our proofs when we get to our assessments, your first reasoning is always going to be given. So you should at least get 1 point on every proof, right? It's always going to be given, that very first reason. Now we need to prove that last congruent statement. Triangle ABC is congruent to triangle ABC. Now when we last talked, we were looking at congruence, and we were talking about you don't need all 6 parts of triangles to be congruent to prove them congruent. You just need to have a pattern of 3 of those things congruent, like SSS or SAS. And in this section, ASA or AAS. If we get one of those 3 orders of congruent parts, then we can prove the triangle's congruent. Now, as far as proofs go, the next step that you're looking for is you're looking to prove on your triangles, you're looking to prove something that you don't have any, you don't need markings to prove that something is true. Now those 2 things are what's called the reflexive property, which we discussed very briefly in chapter 2, and now in chapter 4 we're going to use it a ton. And also you're looking for vertical angles. Those are two things that you can prove without any given information and without anybody putting markings down saying, hey, these two parts are congruent. You don't need markings, you can still prove things are congruent. So what the reflexive property is, reflexive property happens anytime two shapes share a side or an angle. So from right here to right here, AC is part of both triangles. So we're going to say AC is congruent to AC. So your next step, after you do your given, you're looking for that reflexive side, if you have a side that is paired up, or you're looking for an angle that overlaps, that's part of both triangles, or you're looking for vertical angles where that X formation happens, and then you can prove using reflexive property or vertical angles that those parts are congruent. I'm going to go back up and I'm going to erase that drawing I made. Instead of that drawing, I'm going to put this. I'm going to put a mark to show that those line segments are equal. Now we'll get to 2, we'll put reflexive. Well, we're getting there.
If you mark it at the bottom of the computer?
You don't have to. It's just more for your own visual. So if you can imagine, like you're doing on a computer, okay, I already got that side congruent, you already know that, you're good. It's just to help to get to where we have to do ASA or AAS, to kind of see where we have it. Okay, so far we've got the given information, those top angles. We can see those marked already. We've got that reflexive side. So far we got AS. Now we look down to where that C is. We've got that 90-degree box, and we go back to our given. AC is perpendicular to BD. So two lines are perpendicular. What angles are they meeting at? At 90s. So down at the bottom of the, or actually to the right of that, those triangles, number 3, we're going to start to say that angle ACB is congruent to angle ACD, and the reasoning is all 90-degree angles are congruent. So all 90s are congruent. So because it's perpendicular, it forms 90s, and then since we have 90s, they are going to be congruent. Now when you're writing your angles, just a little piece of advice, use this congruent statement up here. So ABC, ADC, those are those letters that match up. So if I go ACB, I went A first, then C, which is the last letter, B, I got to go ACD. So you can use that congruent statement to write those angles to make sure you're matching up the correct letters. And then there's your reasoning. All 90s are congruent. Now you do a little check up there. Do we have 3 pieces of information yet? You bet. We've got an angle, we've got a side, we've got an angle. So now we can just recopy the congruent statement. So the prove part, we've got triangle ABC is congruent to triangle ADC. And the reasoning is angle, side, angle. And there we're done. Usually mathematicians at the end will put a little box. That's a tombstone. That means that the proof is dead. You proved it. Everything's good. Yes? For this? You will. Oh, you will have, so this, you're going to have a drag and drop matching. So you'll have the statement, and then you just need to drag in, okay, given goes here. Okay, second, this statement is proven by reflexive. This is proven by all 90 equal. No writing. So that's because the symbols and things take too long for you guys to type, so just drag and drop, complete the proof. So you'll get a word bank of all your reasons, and you got to drop in the correct reasons. Does that make sense? And I have a practice one. I will show you that before you leave today because you guys won't be here before the quiz. So we'll do that next after this. So we'll do one more proof. Number 4, given QR is congruent to TS. So number 1, QR is congruent to TS. Well, that's some good information. So we already got a side that we know is congruent. So we just need to kind of work on two more things now. Next we have is QR. Put a little comma here. QR is parallel to TS. And both of those are already marked on my figure up there, so I can see that. And number one, we always know that's going to be just our given. So on your quiz as well, the images that you won't have markings, or you'll have to draw out your own figure if you want to on paper. So if you like to make your own markings, you can just quick make a sketch of it and kind of mark out what you got, so you can find three parts that are congruent. All right, we're on to number two. So number two now, we're going to look for something we can prove without any markings. So do we see any reflexive or vertical angles up there? We see some reflexive. So which side is shared between the two triangles? QT. So we're going to next move to QT. Is congruent to QT. And that's going to be reflexive. And heading up to QT, we'll mark it with 2 because we've already got a side marked with 1. So that's going to be our next part. So now we've got a side and we've got another side, but is that enough to prove two triangles congruent yet? We got 2. How many more do we need? Something else. And here's where we get into parallel lines. Now, last chapter we did a lot with parallels. You have 2 parallel lines, and then think of this QT. This is like your transversal. Now, it might be a little more familiar if I extend this out, and then you've got this transversal cutting through. You guys remember seeing these diagrams from chapter 3? We got the same things happening again. Now, in those triangles, we've got alternate interior angles. Now, I got to be specific about which ones I choose. If I choose this one and this one, that's going to give me ASS. Can I use ASS to prove triangles? No, I can't. But if I choose between the two sides I know, that one and that one, it doesn't show up very well. Now what do I have? Angle, side, angle. Okay, so that's what I'm going to use. So heading back, let's get it so we can see those. We're going to start to prove next this angle right here is congruent to this angle right here because of angle alternate interior angles. Now I'm going to write my 2 angles congruent to each other. So let's head back to step number 3. We're going to say RQT. So I look up at my congruence statement. If I did R to Q to T, that's going to be congruent to STQ. So I'm just following the same order of those letters, and then that's going to give me alternate interior angles. That'll be my proof for that. I'm using AIA as an abbreviation. When on your quiz, you'll see the full alternate interior angles. It'll all be written out for you. But if you want to, when you're working on your written proofs, you can go ahead and just put AIA. Lastly, we have enough. We already decided we do. We got ASA, so now we can rewrite the congruent statement. QRT is going to be congruent to TSQ. And reasoning is side angle, side, excuse me. Side angle, side. There would be our reasoning. So everything, all our bag of tricks is coming out to play. We can use SSS, ASA, SAS, AAS. We've got 4 different proofs that we can use to get this one complete. So to recap, always start out with the given. So get all that given information. That's your first step. Second step, you're moving right into looking for either a reflexive, so a side they share, or those vertical angles. You get something that's not marked. And then you got to use some of that given information. Parallels, perpendiculars, you can start to figure out some more angles, sides that are going to be congruent. Midpoints also.
Yeah, so I think now, like,
well, what does the direction say to do? Well, if it's kind of cut off, you can just pull up the digital version and kind of look at what that one was and then see. Yeah.